Good morning to all. Welcome to DTA Studio. Now, I will brief about what happened in the previous class. Basically, this 8051 microcontroller, it supports serial data communication. Means the transmission of the data and the reception of the data is placed serially, not parallelly. Serial means bit by bit. In addition with that, in the previous class we discussed for this serial data communication, two registers in 8051 they will support. The first one is called as the SCON register. First one is called as the SCON register, and the another one is called as the SBUF register. In the earlier class, we discussed what exactly this SCON. SCON means serial control register, and what is the bit structure, and what is the function of each and every bit. In this class, we move to the second register, which helps for the serial data communication in 8051 microcontroller. That is the SBUF register. SBUF register. The full form of the SBUF register is serial buffer register. Please remember, buffer is nothing but the temporary storage or temporary memory. Similar to the SCON register, this SBUF register is also an 8-bit register. It's an 8-bit register. The bit structure starts from D0 ending with D7. Similar to the SCON register, the SBUF register is also an 8-bit register. Then what is the main function of this SBUF register is, this register is used to hold the data. In the other sense, it is used to store the data for the serial communication. For the communication, data is needed. So that this SCON register, it will control the transmission and reception. But which register stores the data or holds the data? This SBUF register, it holds the data before the transmission and after the reception. So that's why SBUF register is used to hold data for serial communication. Not only to hold the data, it is also helps to transmit the same data and also to receive the same data in the other side. In the source side, it helps to transmit what the data it is stored earlier, and also at the receiver side, it helps to receive the same data. And this 8-bit register, that is SBUF register, is again divided into two types. One is called as the write-only register, another one is called as the read-only register. One is called as the write-only register, another one is called as the read-only register. Now come to the what exactly write-only register and read-only register. Here, as the name itself indicates, just imagine 8051 microcontroller kit is there or board is there. From the 8051 microcontroller to the other devices, we can transmit the data, some data. For example, during interfacing, from 8051 microcontroller, you would send the data to the stepper motor, DC motor, or traffic light controller, like this. Okay, whatever the data sent out from the microcontroller, the data is stored in the write-only register. That means this register is used to hold data to be transmitted, goes out. Transmitted means goes out from 8051 microcontroller via a pin called as TXT pin. TXT is nothing but what? Transmission pin. Okay, in 8051 microcontroller pin diagram, the pin number 3.1, that means port 3.1. This pin is used for to transmit the data out of the microcontroller to the other devices. Okay, so that this write-only register, it is used to hold the data which is transmitted out of the 8051 microcontroller via means through the pin TXT. Similarly, the read-only register, it will perform the opposite function of the write-only. Means after transmission, what is the next function? It's the reception, receiving of the data. So at the another time, whatever the data we have transmitted, it is received. That data, received data, is stored in the read-only register. Means this register is used to hold the data received from the external sources. Means in the beginning I told you that from the microcontroller, whatever the data goes out, it is stored in the write-only register. So similarly, in the another side, if the microcontroller get the data from the external resources, if it is get the data from the stepper motor or it may be from the DC motor, whatever the data the microcontroller kit can get from the other devices, that data is stored in the read-only register. the data is available or it comes to the microcontroller via pin that is called as the RxD pin, that is called receiver pin. And in the 8051 pin diagram, the pin 3.0 means port number 3, where the first pin is there, no, that is called as the P 3.0. So in the write-only register, the data goes out from the microcontroller to the other devices. The data is stored. But in a read-only register, in the opposite side, the data comes from the external devices to the microcontroller. That's why it is used to hold the data received from the external sources. External sources means it may be a DC motor, stepper motor. The data is received from the external sources via this pin number, that is called as the RxD pin or receive pin, that is the pin 3.0. That is about the SBUF register. There is no detailed structure for the SBUF register. Okay, there is only a types of the SBUF register and what exactly it will perform. Now we are move on to the baud rate. Based on this baud rate, some problems are there in the microcontroller according to syllabus. So what exactly the baud rate? So in communication, there are two common words. One is called as the baud rate, another one is called as the bit rate. There is a difference between the baud rate and the bit rate. For example, baud rate is nothing but it is defined as the number of symbols transmitted per second, not per minute, not per hour. Okay, number of symbols. Here, symbols are nothing but there is another meaning for the symbol that is also called as the character. Symbol is also called as character. For example, A is the symbol or character. Similarly, B is the symbol or character, and the group of character hello is the group of characters or symbols. How much number of symbols transmitted per second? That is called as the baud rate. Bit rate means how much bits are transmitted. For example, 0 is the one bit, 1 is the another bit. Like that, how much number of bits, binary bits are transmitted per second, that is called as the bit rate. But baud rate means how much number of symbols. Please remember, a symbol or a character is a group of more than one bit. A symbol or a character is a group of more than one bit. That's why here the second points indicate that each symbol may consist of more than one bit of information. A means the A is converted as a minimum 2-bit information, maximum 8-bit information, like that. Okay, it should not be 1 bit, because if it is become 1 bit, then it is called as the bit rate. Now we are discussing baud rate. That's why whatever the symbol or character is there, no, each and every character or symbol is converted into a more than 1 bit. It may be a 2-bit, 3-bit, 4-bit, like that, up to maximum of 8-bit, because 8051 is the 8-bit microcontroller, not more than the 8-bit. Each and every character what convert. And here there is a relationship between the bit rate and the baud rate that is given by the equation. That means bit rate and baud rate are related as given by the equation. Bit rate is equal to, please remember, bit means zeros and ones, baud means it's a symbol. Okay, bit rate is equal to baud rate into number of bits in each symbol. Baud rate into number of bits in each symbol. Okay, I already told you A may be converted into a 2 bits or 3 bits up to maximum 8 bits. So how much bits you are converted? So that is number of bits in each symbol. This gives the relationship between the bit rate and the baud rate. So now here is a formula, standard formula to calculate the baud rate. Baud rate is given by the equation crystal frequency divided by 12 into 32 into 1 divided by 256 minus TH1. Please remember, crystal frequency is nothing but 8051 microcontroller having a standard crystal frequency, because in 8051 microcontroller, the crystal frequency is used to generate the clock pulses. There is a inbuilt clock pulses, because when 8051, when there is a timer, there is a inbuilt crystal, it produces the clock pulses. When it acts as a counter, we should provide the clock pulses externally. In the previous class, I told you. So that the crystal frequency is around 11.0592 megahertz. This is the almost, sometimes we are called as 12 megahertz. So this is the standard crystal frequency in 8051 microcontroller, that is 11.0592 mega, 10 to the power of 6 hertz. Divided by 12 into 32, here 32 indicates in 8051 microcontroller, there are 32 input-output pins are there. There are 32 input-output pins are there. Okay, into 1 divided by 256 minus TH1. 256 it indicates the maximum address level. TH1 is nothing but is the timer. Okay, because the timer is divided into TH0, similarly TH1. At the same time, TL0, TL1. Okay, in the previous class I told you it's because 8051 supports to the 16-bit timer as well as 16-bit counter. That 16-bit timer is again divided into 8-bit, 8-bit. So one is called as the TH1, another one is called as the TH0, similarly TL0 and TL1, like this. Okay, and here TH1 is the very important one where we are storing the baud rate. TH1 is indicate it's a timer 1 in mode 2. TH1 indicates it's a timer 1 in mode 2. In mode 2. You already knew that what is mode 1, mode 2, all those things in the previous classes. Here TH1 is the timer 1 in mode 2. So that the baud rate is given by the equation crystal frequency. In majority of the problems, in the problem itself they mentioned what is the crystal frequency. That is the 11.0592 megahertz divided by 12 into 32 into 1 divided by 256 minus TH1. This is the standard formula or ready formula for the calculation of baud rate. So here, how do you calculate the TH1? In this formula, there is a TH1. To calculate the TH1, in the problem, if they are not given the TH1, then there is a formula to calculate the TH1. TH1 is equal to 256 minus crystal frequency divided by 12 into 32 into baud rate. Okay, if you know the baud rate, then you can easily calculate the TH1. If you know the TH1, you can easily calculate the baud rate. They are interrelated. Okay, but in the problem, they may give either baud rate or TH1 value. Okay, if any one value, if they are given, then it is very easy to calculate the remaining parameters. Okay, if they are given TH1, then the standard value is there for the crystal frequency, then you can easily calculate the baud rate. If they give baud rate, if you want TH1, this parameter, then you should use this formula 256 minus crystal frequency divided by 12 into 32 into baud rate, then it is very easy. Okay, so here, see here, in the problem, okay, you should write an ALP, that is the assembly language program. In the assembly language program, there is no provision to directly move to a resistor or to the accumulator these decimal values. Commonly, there are 4 baud rates are there. 4 baud rates are used in the 8051 microcontroller. The commonly or widely used baud rate is 9600. All of you already done in the interfacing experiments while selecting the baud rate. Majority of the people you selected 9600 baud rate. Sometimes 4800. Half of the see here, half of this 9600, 2400, half of the 4800, and 1200, half of the 2400. If you remember this one, then degrade into a half of 50% of this one, you can get the remaining baud rates. But it is not, there is no any provision to directly push this decimal value, that's a decimal value, to any resistor or to the any accumulator while writing the assembly language program. That's why there is an alternate hexadecimal value for each and every decimal. In front of this one, your normal rate H is nothing but what? Hexadecimal. For 4800, that is the FA, and 2400, that is the F4, and 1200, that is the EA. Better to remember these 4. Otherwise, you should calculate first how then convert into a FD, then convert into hexadecimal, then only you can write the assembly language program. So better to remember these baud rates and what is the hexadecimal alternate value for each decimal value. 9600 is a FD, 4800 is a FA, 2400 is a F4, and 1200 is the E8. These are the 4 baud rates we are commonly used while interfacing, while transmitting the serial data from microcontroller to the other devices, that is the external devices. Okay. Now, this is the last topic in the 8051 microcontroller, the working of serial port. I already told you 8051 supports only serial data communication. For serial data communication, we require a serial port. Okay, there are different ports are there, serial port, parallel port, USB port, like that. But here, serial port required for serial data communication. How it will work in 8051 microcontroller? You might have observed in the kit, 8051 microcontroller kit or board, there is a serial port is there. So how it will work? See here, the clock for the serial port means for the serial data transmission, we require a baud rate. For serial data transmission and reception, we require a baud rate. For this baud rate, we require a clock. For this baud rate, we require a clock. So that how to produce the clock by using timer 1 working in mode 2. That mode is called as the 8-bit auto reload. In the earlier class, I told you, okay, when the timer 1 means TH1. TH1 is called as the timer 1. TH0 is called as the timer 0. Okay, when it is working in mode 2, it acts as the 8-bit auto reload. So that's why what the first point is now we are indicating that the clock for the serial port, to generate the required baud rate. To generate the required baud rate, like 9600, 4800, 1200, 2400, any one baud rate. To generate the baud rate for serial data transmission and reception is provided by which one will provide this clock pulses and baud rate? This timer 1, especially when it is working in the mode 2. Timer 1 should not working in the mode 0. It should working in the what? Mode 2. Mode 2 is nothing but what? 8-bit auto reload. There are two modes are there, mode 1 and mode 2 generally. Mode 0 you are not used commonly, mode 1 and mode 2. So here the timer 1 should work in the mode 2, then it will helps to generate the required baud rate. When the baud rate is generated, that baud rate is stored in the TH1, okay, TH1 that act as the clock for the serial port. When everything is happened, that is the baud rate is generated, clock pulses are generated, then the serial transmission and reception automatically what's called happens. So after this one, the SCON register is loaded with the required serial mode. The SCON register is a serial control register. I told you in the previous class. So this SCON helps. There are 4 serial modes. 00 is called as the serial mode 0. 01 is called as the serial mode 1 with the 8-bit data, 1 start bit and 1 stop bit. And 10 serial mode 2 and 11 that is serial mode 3. We have start from 0 ending with 3. But among these 4 serial modes, the 8051 microcontroller commonly prefers or we are widely used this 01. 01 is nothing but which mode? It is the serial mode 1. That is the second mode. Serial mode 0, it is not widely used. Serial mode 1 is widely used because it consists of a start bit, one start bit, especially at the left hand side there is a start bit and another side there is a stop bit. Okay, in between start bit and stop bit there is a 8-bit original data is there. Totally it becomes 10 bits. See here there are 8 bits of data at the center. Consider this the data is starting from D0 ending with the D7. At the left hand side there is a start bit, it's 1 bit, and at the right hand side there is a stop bit. Then it is also 1 bit. Start bit left hand side, stop bit right hand side. So these are the 2 bits plus 8 bit in the middle, that is called as the data frame or data bits. This is the original data. So totally it becomes what? 10 bits in the serial mode 1. Microcontroller always prefers serial mode 1. Okay. And to serially transmit the data is written to SBUF register. Okay, SBUF register means here I have told you it's a 8-bit register. What is the 8-bit data is there? This we should write this data into a SBUF register. SBUF it will force the data before the transmission, and after the transmission at the receiver side it receives the data. Again it will store the or hold the data. Okay. So first thing is the SCON register is loaded into the required serial mode. There are 4 modes are there, but what we are required? Serial mode 1. It is widely preferred. Please remember, in the serial mode 1, it consists of the 1 start bit, 1 stop bit, and 8 bits of data. These 8 bits of data is stored in which register? That is the second register. That is the SBUF register, serial buffer register, temporarily till transmission. Once the transmission is over, the data is become 0 in SBUF register. This is the third step. Then what happens after storing the data in the SBUF register? As soon as the data is moved to the SBUF register, original data, when it is 8-bit data is moved to the SBUF register, then it is framed with the start bit and stop bit. I told you no. Okay. As soon as the data is stored in the SBUF register, 8-bit data is stored in the SBUF register. In the left hand side, start bit is attached, and in the right hand side, stop bit is attached. That is called as it is framed with start bit and stop bits. Both are 1 bit, start bit and stop bits. After data is framed, now the data frame is transmitted 1 bit at a time on TXT pin. 1 bit at a time is serially. Okay, if all the bits are transmitted, then it's called as the parallel. But 8051 microcontroller not supports for the parallel data communication. That's why after the data is framed with the start bit, stop bit, and the middle 8 bits of the data, now the data frame, that means the data bits are transmitted bit by bit or serially. In which pin? On TXT pin. TXT pin is nothing but what? It's a transmission pin. So after all the bits are transmitted, what happens? See here, once the serial transmission is complete, after all the bits are transmitted, stop bit is also start bit. It will initiate, begin. It will start in the means it will transmit it first, followed by the 8 bits of data. Finally, stop bit is transmitted. Once the transmission is complete, then the TI flag. Please remember, in the SCON register, the second bit is called as the TA flag. First bit is called as the RI flag, receive interrupt. Similarly, second bit is called as the TA flag, that is transmit interrupt. Once the serial transmission is completed, over, all the bits are transmitted, then the TA flag is raised to 1 or is set to 1. It indicates that all the bits are successfully transmitted to the receiver side. Now it is ready to take the next data. Now it is ready to take the next data. When TI is raised to 1, till the transmission is over, TI is equal to 0. Once the transmission is over, all the data bits are transmitted to the receiver side, then TI is automatically raised to 1. 1 that indicates that, see here, it's indicating that the user can write the next data into the S box. Means transmission is over. Now the user can write or can store the next data wanted to transmit into the what? SBUF register. That is what? Indication. Okay. In this way, the serial port work in 8051 microcontroller. Now, how the serial data transmission takes place? Next slide, we move on to how the serial reception takes place. Till now, we discussed about how the serial port work. In the serial port, 2 operations takes place. One is the serial data transmission, another one is the serial data reception. How the serial data transmission takes place? Here we will discuss step by step. The following steps are used to program the 8051 for serial data transmission. Okay, the first step is called as the TMOD register is loaded with the value 20H. See here earlier. Okay, the first register, TMOD register, TCON register, SCON register, SBUF register. We require the basic data. Okay, for discussing these steps. The TMOD register is also 8-bit register. No. Okay, the TMOD register is loaded with the value 20H. 20H is nothing but in the bit structure, every bits are converted into hexadecimal, it becomes 20H. That indicates, so now it is in timer 1 and acting in mode 2. Okay, when TMOD is loaded with in the program, in the next slide we will discuss the program, how to load the TMOD register with 20H. As soon as you are storing the TMOD register with 20H of data, it automatically acts as what? Timer 1 in mode 2. Mode 2 is nothing but 8-bit auto reload. Mode 2. Mode 1 means 16-bit timer, but mode 2 means what? 8-bit auto reload. Okay, I told you why it is called as auto reload. One time loading takes place, still original value is there in the TH1. Second time also loading takes place. That is called as a reloading. That's why it's called as the 8-bit auto reload in the second class. So here, as soon as you are storing 20H, it indicates that now it is acting in a timer 1 and mode 2. That is auto reload. Okay. To set the baud rate, here we should fix the baud rate. Now, after loading 21H, next step is the TH1 is loaded with the 8-bit appropriate value of the baud rate for serial data transfer. Before transfer the data serially, so for the TH1, we should move the appropriate baud rate. Appropriate means there are 4 baud rates are there. I told you 9600, 4800, 2400 and 1200. Which are the baud rate you want? We can what's called load that baud rate appropriate. Which one you want? You can load that appropriate value to the TH1. TH1 is a 8-bit register. 16-bit timer is divided into 8-bit timer plus 8-bit timer or 8-bit register plus 8-bit register. In TH1 is the high bit register. You should fill here TH0 is a low bit register. Okay. So that in the TH1, you should load the 8-bit appropriate value of the baud rate for serial data transfer. You can load any among 4 baud rates. Okay, they are automatically converted into 8 bits of the, because it's a what this TH1 is basically, it's a 8-bit register. Okay, so that every baud rate is converted into 8 bits. Then we should load that 8-bit baud rate into a TH1. Fine. Then next step is the SCON register is loaded with, previous class I told you, SCON register is loaded with 50H. Why 50H only? Because in the 8051 microcontroller, the mode 1, serial mode 1, second mode, okay, it is widely used. 99% of the communication in the 8051 microcontroller prefers serial mode 1. In the serial mode 1, if you convert all the 8 bits, so you can get the hexadecimal number 50H. Okay, better to see the previous slides where if you convert all the all the 8 bits into hexadecimal, you can get the 50H. That means hexadecimal value 50H. If you load this 50H into a SCON register, then it automatically add in serial mode 1. Okay, so that TH1 should be loaded with the baud rate. SCON you should always load it with the 50H. Then it's automatically act in which mode? Serial mode 1. That is 8-bit data. I told you, and 1 bit of start bit, 1 bit of stop bit. Totally, there are 10 bits. Now, after loading the 50H into the SCON register, then TR1 is set to 1. TR1 is nothing but what? It's a timer 1. Timer 1. Start and stop bit. TR1 bit. So, in the bit structure of the timer, there is a TR1. You should set the TR1 into a 1 to start the timer. If the TR1 is equal to 1, okay, it will start the timer. If TR1 is equal to 0, it will stop the timer. Like that. Okay, so that TR, now you wanted to transmit the data serially, then you should set the TR1 is equal to what? 1. TR1 is equal to 1. That's what here it's indicating. TR1 is set to 1 to start a timer. Okay, after set to 1, this TR1, TA is cleared by CLR TA instruction. TA is what? Transmit interrupt flag. So TA is the second bit in the which register? SCON register. First bit is called as the RI, receive interrupt. Second bit is called as the transmit interrupt. If TA is equal to 1, then transmission will not happen. Transmission will not start. To start the transmission, this TA should be what's called 0. Okay, there is no any interrupt. Okay, that's why if there is earlier, if the TA is equal to 1, now you should make it clear by using this instruction CLR TA. CLR means if it is earlier it is 1, then it automatically removes the 1 and stores 0 in the TA position. Means there is no any interrupt for transmission. TA is nothing but what? Transmit interrupt. If it is 0, then there is no any interruption for transmission. Now the transmission will begins. Okay, please remember. So if it is 1, then we should use this instruction CLRTI so that it clears the 1 and stores the 0. Now the character or symbol to be transferred serially is written into the SBUF register. Okay, everything is now. Transmission is ready because we have cleared the TI flag, transmit interrupt flag, we have cleared it. Okay, now we want original data for transmission. If there is data, only transmission happens. So that whatever the data, 8-bit of data, means each symbol or character is converted into 8-bit of data. I told you A is the one symbol or character, B is the one symbol or character. Like this, LO is a group of the characters or symbols. Whatever you can give, it is converted into 8-bit data. For example, in hello, H is converted into 8-bit data, E is converted into 8-bit data. Like that, all symbols are converted into 8-bit data because it is what? SCON, SBUF, all are the 8-bit registers. So that whatever the data you wanted to transmit, means symbols or characters, first load into the or store into the what? Return into the SBUF register. Because once you return it to the SBUF register, it will hold it. Okay, I will tell you which instruction is used to write the symbol or character, means data into the SBUF register. Okay, after loading into the SBUF register or after storing into the SBUF register, now the TA flag bit is monitored with the use of the instruction wait : JNB TI, wait. See here, Now the transmission is begins. We should wait the what's called this TA flag. Earlier TA flag is what is clear 0. Okay, until all the bits are transmitted, the TA is 0 only. Once the transmission is over, the TA is again raised to 1. It indicates that every transmission is completed, so that you can transmit the what next symbol. The previous transmission is completed, you should start the next transmission. That's what we are indicating. The TA flag bit is monitored. You should monitor the TA flag always, whether it is 0 or 1. Until 0, transmission is continuous. Once it becomes 1, the transmission stop. It indicating that previous transmission is completed. Previous character or symbols are what's called transmitted completely. Now it is ready to transmit the next symbol or characters by using this instruction. In the ALP, we should write this instruction, wait JNB. JNB means jump if bit is equal to 0. Okay, which bit? TI bit. Until TI bit is 0, it will this loop will continue. Jump if bit is equal to 0, which bit? It's a TI. Okay, it go to the wait, and again this loop is continuous. Next, jump if bit is equal to 0. Yes, bit is equal to 0. Now again loop will continue. Once TI is equal to 1, it will check. Jump if bit is equal to 0. No, now the bit is 1 because all the symbols are transmitted. Now the loop will not continue. Loop will what? It will discontinue. Okay, till the bit is equal to TI is equal to 0, transmitting to the flag is this bit is equal to 0. The loop is what's called, it is again and again it's correcting. Okay, once TI becomes 1, TI become 1, so it will not satisfy this condition because jump if bit is equal to 0. Only when the bit is equal to 0, it will jump. Otherwise, it will not jump. Otherwise, loop will not continue. Okay, once it become 1, okay, the loop will not continue. It indicates that the transmission is over. Okay, so that by using this instruction to see if the character has been transferred completely. Okay, so if it is 1, then to transfer the next character or next symbol, okay, then go back to the step number 5. Go back to the step number 5 because once the transmission is completed, TI is what? Set it to 1. Now we want, before transmitting the next symbol, go back to the step number 5. What is there in the step number 5? TI is cleared by using the CLR TI instruction. See. Okay, again you should clear before transmitting the next symbol. You make it as TI is equal to 0, then store the next symbol in the SBUF register and start the transmission. Okay, so again like that you should start from the step number 5. Clear, transfer, like this. This is about the how the serial data transmission takes place in 8051 microcontroller. Now, in the another side, how the serial data reception. Once the transmission is over, another side, external devices, how they will receive the data. Okay, the step number, almost similar steps. Wherever the transmission word is there, just replace the reception word. Okay, see here, the following steps are used to program the 8051 for serial data reception. Just compare the previous slides, transmission slide and the reception slide, almost all the same. Okay. The TMOD register is loaded with the value 20H. Same point. Again, you load the TMOD register with the 20H, indicating that what? It is acting timer 1. In which mode? Mode 2. Mode 2. That means 8-bit auto reload. Okay. Same. First step is same for transmission also, reception also. So for what purpose we are load the 20H to the TMOD register? To set the baud rate. 4 baud rates are there. No, which baud rate you want? Okay. Now, see second step, the TH1 is loaded with the 8-bit appropriate value of the baud rate for serial data receive. Same step. Their transmission word is there, but here receive word is there. That's it. Okay. So that which baud rate you want. Okay, that baud rate is converted into 8-bit while doing the ALP assembly language programming. The baud rate is converted into a 8-bit. So that we should load that 8-bit appropriate value of the baud rate into the what? TH1. TH1 means timer high. Okay, it's a 8-bit register also. TH1 is the 8-bit register. That's why load the 8-bit value of the baud rate. Okay. Now the starting 2 steps are same. Just you should replace the transmission word by what? Reception word. Third one, the SCON register is loaded into the value 50H. Same. Okay. Indicating that 50H is nothing but what? It is acting in serial mode 1, where there is a 8-bit of data and 1 bit of start bit and 1 bit of stop bit. Third step is also same. Okay, now it's a fourth step. TR1 is set to 1 to start the timer. It is also same because we are dealing with the timer 1. Okay, in mode 2. So that TR1 is set to 1. If it is 1, then we start the timer. If it is 0, we stop the timer. Okay, now RI is clear. In the previous slide, it is a TI, transmit interrupt flag, because at the time we are dealing with transmission, but now it's a reception. That's why instead of TI, now here there is a small changes. RI is cleared by CLR RI. There CLR TI, now CLR RI. Before reception, if the just check whether RI is 0 or 1. If the RI is 0, no problem. Reception is happens. Okay. If the RI is 1, that indicates that there will be interrupt in the reception. It will not receive any data. Interrupt means disturb, stop. Okay. That's why if RI is stored with 1, now we should clear this 1. Clear means make it 0 by using the instruction CLR RI. It clears the receive interrupt flag. Clear means make it 0. Okay. There is a small changes in the fifth step where DI is there, here it's a RI is there. Okay, sixth one. The character or symbol to be received, there transmitted, here it's a received. Serially is written into the SBUF register. Which data you want to receive? You should write that register, write the data into the SBUF register. Okay, the copy of the data you should write into the SBUF register. Fine. Now, the RI flag bit is monitored. That is receives interrupt flag bit, that is the first bit in the SCON register, you should monitor. Okay, because until 0, reception is continuous. Once it becomes 1, reception stop. That's why you should monitor by using this instruction, wait, JNB RI wait. In the previous slide, wait, JNB TI. So just change RI. Okay, if jump bit is equal to 0, then loop will continues. Till RI is equal to 0, the loop will continues. Means it will 0 only till all the symbols are received. Okay, successfully. Once all the symbols are received, okay, then RI is goes to 1. But this instruction indicate what? Jump only if bit is equal to 0. But now the bit is equal to 1, so that it will not jump. So that you should always monitor that what happens in this RI flag. If it is 0 or 1. Okay, once it becomes 1, it indicates that all the characters or symbols are received completely. Okay, reception success. Okay, once all the bits, all the symbols, okay, characters are received successfully. Now, if you want to receive the next symbol, then go back to the step number 5. Okay, means now once all the symbols are completely received, RI is what? It is set to 1 now. If you want to receive the next symbol, now make it RI is clear. Make it RI is 0. Once it becomes 0, it is ready to receive the next symbol, or it is ready to receive the next character. So that by using this instruction, JNB RI wait, you should always observe what happens in the RI flag. Okay, this is about the 8 steps on serial data reception. Now some of the simple problems. Okay. Based on the simple problems, we move on to the ALP. ALP is also very easy here. Just see one problem, similar problems, but only the data is changed in the what's called in the question papers, or it may be in the syllabus copy. Just they will change the data. That's it. Write a program. Program means ALP here to transfer a letter A. Here we are considering only one letter or character or symbol. Same name. A serially at 9,600 baud rate. They given baud rate 9,600. That's why I told you in 8051 microcontroller we are always prefer 9,600 baud rate. Okay, continuously for a crystal frequency. See, they are already given the standard crystal frequency of 8051 microcontroller 11.0592 megahertz. Okay, so here, so they told that this is serial communication. So that I told you in the steps, TMOD should be loaded with 20H. In the problem, they're not given, so that you should consider yourself. TMOD should be 20H. SCON should be what? 50H. TMOD should be 20H is what? It is timer 1, acting which mode? Mode 2. Okay. If they are not given in the question paper, you should consider. Okay, TMOD should be 20H. Okay. For serial communication, TMOD always should be 20H. And SCON should be 50H. SCON should be 50H means serial mode 1. Okay, it's a common mode or widely used mode for serial communication where one bit start bit, one bit stop bit, one bit stop bit, and 8 bit of what? 8 bit of what? Data. Totally, it's a 10 bits. Totally, it's a 10 bits. Okay, so and next one, we should calculate the TH1. TH1. Previous formula I told you no. TH1 256. Same formula I am applying here. 256 minus crystal frequency divided by 12 into 32 Baud rate. Okay. Since they are Baud rate they given and crystal frequency they given, this is the suitable formula where TH1 is equal to 256 minus this crystal frequency 11.0592 mega means 10 to the power of 6 and 12 into 32 Baud rate they have given 9600. Okay, and TH1 is equal to 256. If you are calculating this value, finally you can get 3. 256 minus 3, you can get 253. 253 is nothing but what? FDH. That's why in the previous slides, I showed one picture, one tabular column where 9600 is a decimal value. Hexadecimal value is how much? FDH. So finally you got the same answer here, FDH. Okay, it is a hexadecimal value. If you remember that value, no need to calculate this much. Okay. So next, based on this one, you should write the program. You should write the program, ALP program. Following the 9 steps. See here. First one, move. It may be in uppercase letter or small lowercase letter, no problem. Move. It's ALP. Move T mod with 20H. Okay. I told you no load. T mod resistor. See. Loading takes place from the right hand side to left hand side. T mod resistor with immediate value of 20H. Hash means what? Immediate value. Okay. Similarly, SCON, how much? 50H because it is acting in serial mode 1. So we are moving 50H. And now TH1, we are moving a Baud rate. To the TH1, since it's a 8-bit, see here, TH1 is basically 8-bit. Okay. How can you move 9600 Baud rate? It's a decimal value. But it's a 8-bit resistor. So that's why this decimal value you converted into what? FDH. Okay. So that's write F in 4 bits and write D in what's called 4 bits. Totally it become 8 bits. Now it is very easy to move to the TH1 resistor. TH1 is also 8-bit. F you can write 4 ones. You already know that. F is nothing but 15. 4 ones. T is nothing but what? A is nothing but 10. B is nothing but 11. C is nothing but 12. D is nothing but 13. 13 we can write like this, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. How much you want? 13 you want. So 2 to the power of 3 is equal to 8. Still you want 5. 2 to the power of 2 is equal to 4. Still you want 1. So that 2 to the power of 0 is equal to 1. 8 plus 4, 12. 12 plus 1, 13. So make it 0. Make it, this one is 0. So that 1, 1, 0, 1. Okay. So 1, 1, 0, 1. This 8-bit is automatically loaded to the TH1. That's why 9600 should be converted into an 8-bit and it is FDH. So now set to B TR1. Now I am starting the timer by using the set bit TR1. So now whatever the data what they are given A. So stored in the SBUF register. See here again it's a loop. Move A. The value they are given, serial data they are given, it's a. Move to the which register? SBUF register. It will hold. And after that one, see here, wait for the TI is equal to monitor the TI. Same instructions here, wait, JNB, TI, wait. I told you the previous, you should monitor this TI. Okay, earlier you are cleared this TI so that transmission of the A happens in terms of bit by bit. A is also converted into 8-bit of data. 8-bit, it automatically converts A into 8-bit of data so that this data is transmitted bit by bit. First bit, second bit, third bit, fourth bit, like that. Once until the 8 bits are transmitted, TI is equal to 0. That's what it's waiting. Once all the 8 bits are completed, TI become 1. So that what happens in the next step? Clear TI. Because there is a next transmission should be happen. Okay. That's why once TI become 1, clear TI. Make it again 0. So SJ, short jump, again means it goes to here, then move the new data. Move SBUF in the place of the new data. It may be a B, C, or it may be hello. Okay, it's a group of characters or symbol. So that this loop will continue until TI becomes 1. Okay, so once TI become 1, clear, again you can send the new data. Okay, like this, you can write the ALP for the serial data transmission. This is the problem for serial data transmission. Now last problem related to serial data reception. In the previous problem, transmission is over. How the reception takes place? So one sample problem is there. Write an ALP assembly language program to receive serial data reception continuously at a baud rate, same baud rate. Okay, that's why please remember 9600 hexadecimal value FDH. No need to calculate all those calculations if you remember. 8-bit data and 1 stop bit for a crystal frequency, same 11.0592. It is a standard in 8051 microcontroller. And place it in the RAM, random access memory with a memory location. They give the address of the memory location 62H, and also send a after storing in the memory location, send it to a port number P2. There are 4 ports in the microcontroller: P0, P1, P2, P3. So that you can send it to P2. So same procedures here. Move T mod. How much value? 20H, because it should be work in timer 1 and mode 2. If you move 20H into the T mod register and move 50H, here I'm just interchanging the steps. You can write this one in the second line, no problem. Okay. Move SCON register with 50H means serial mode 1, where 8-bit, 1-bit start bit, 1-bit stop bit. After that one, see here, FDH. Here in this, I'm not calculating the 9600 baud rate. I'm not converting again into FDH because okay, it's already in the previous problem we were calculated 9600 is converted into FDH. So that move that FDH means baud rate 9600, same value here 9600. Okay, into which register? TH1 register. Timer I. It's a 8-bit register. Okay. Now set the timer TR1. TR1 means start the timer. Okay. Now again here RI. So that if the RI is equal to 0, then only it will receive the data. That's why if it is 0 or 1, better to use this instruction. If you use this instruction, then RI is 0, again it is converted into 0. If it is 1, again it is converted into 0. So that better to use this instruction. Otherwise, the program is stuck in the here itself. If it is 1 earlier, okay. So that again clear RI, make it 0. Now whatever the data, okay, it want to receive, it start from this instruction. Wait, JNB, RI, wait. So jump if bit is equal to 0. Till RI is equal to 0, it will receive the data. It will receive the data. Whatever transmitted from the transmitter side, the same data it is received till the RI is equal to 0. That's why jump if bit is equal to 0. JNB means jump if bit is equal to 0. Wait. Okay, if it is 0, goes to the wait, again this two. Wait, go to the again this two. Okay, so once the reception is completed, this RI becomes 1. Okay, after that one, whatever the data received, that is stored where is buffer temporarily. Okay, serial buffer. Whatever the data received is stored in the serial buffer. So this data is moved to the accumulator. Accumulator is commonly used register to store the result. Okay, here the result is what? Result is the received data. Okay, so that the data is initially stored in the SBUF. Okay, in the problem they given, you should send the received data to the memory location. After memory location to the port P2. Okay, that's why whatever the data received is stored in the SBUF, and again it is moved to the accumulator. So that from the accumulator, see here, from the accumulator, N is accumulator, I move to a memory location. What is the memory location here? 62H. In the problem they are given 62H memory location, RAM memory location. From SBUF to the accumulator, from accumulator to the 62H, that is the memory location. Now finally, according to the problem, from the memory location we move to the port number P2. See here, from the memory location means, see here, from the accumulator to the memory location, no. So in the accumulator, still the copy of the data is present. Accumulator, it not completely send the data. It will send a copy of the data to the memory location. Still original data is there in the accumulator. Okay, see here, accumulator to the memory location, copy of the data, duplicate data. Okay, but still original value is there in the accumulator. So that from that original, from that accumulator, we can send it to the port 2. According to the problem, according to the given statement, we should send it to the memory location also. That is the 62H memory location is the address of the memory location in the RAM, and also to the port number P2. Accumulator, it not completely transmit the data, it will transmit the copy of the data. still the original data is resides or remaining in the accumulator. So finally from the accumulator, I'm sending it to the what? Port number P2. Finally, if you want to transmit a new data, then SJMP again is what? Clear RI. Once the transmission is over, RI is what? Raise it to 1 or set it to 1. Now clear RI, make it 0, and what's called? New data will be received. New data will be received and stored in the SPA accumulator and to the memory location, and finally to the which port you want, you can receive through that port. Okay, now this is about one problem related to the how the data is received through serial port. And finally, these are some of the question banks. You can see these questions in the syllabus copy itself. At the end of the syllabus copy, you can get these sample questions. Okay, sample questions. Almost all the questions are theoretical questions. Few questions based on the problems. Okay, these are the 5 marks questions. 5 mark question. Almost I completed all in the previous 3 classes plus this class. And in the next slide, there will be 10 marks questions. Here, majority you should concentrate towards the bit structure of the TMOD resistor, TCON resistor, SCON resistor. Okay, and these are some of the problems related to this baud rate, bit rate. This completes your 5th unit. That means timers, counters, and I/O ports. Almost all, according to syllabus, all the contents are completed. If you have any doubt, you can ask me.